Hello, sixth graders. Welcome to the learning about energy in this unit. We're going to go right into several different forms of energy. First, we have mechanical energy, which we're going to talk about in a minute and what that is. Then there's radiant, which is basically the energy from light. Then we have sound, things that you hear, chemical energy, heat, which is also called thermal, electrical energy, and then nuclear energy. So when you're talking about all the forms of energy, those are the basic ones that we go. And to remember them, we use this acronym called Mrs. Chen. If you go back and look, all of the beginning letters spell out Mrs. Chen. I also do kind of a little chant that I'm going to get to stick in your head here. I say mechanical, radiant, sound, chemical, heat, electrical, nuclear. Mechanical, radiant, sound, chemical, heat, electrical, nuclear. That's going to stick in your head now, but you might remember it. Mechanical, radiant, sound, chemical, heat, electrical, nuclear. So those are the different forms of energy. You might want to take a minute. You can pause this recording, write those down in your notes so that you have them. And then when you're ready to move on, let's talk about what actually energy is. So energy is the ability to do work. If you're able to do work, something happens, then that is energy. And it can cause change. Usually when you do work, you cause change in some form, and that's energy that's happening. So go ahead and write that definition down, the ability to do work. Remember, you can always pause the screencast. So when you actually do work on an object, some of that energy is transferred to that object. Energy transfer is a big deal in this unit and what we're talking about, and when we do our marble roller coasters, Rube Goldberg projects, all those things have a lot to do with energy transfers. And so you can think, when you think about the transfer of energy, you can work basically is the transfer of energy. And you know how we always have a label that we put on numbers, some type of unit of measurement. If it's a length, centimeters, or if it's a liquid, maybe it's milliliters. When you're talking about energy, it has a unit of measurement that you probably have never heard before, and it is called joules. And it's not the joules like, oh, earrings, that kind of thing. It's spelled different, as you can see, Joules. So that is how, anytime you have a number that is with energy, we label it joules. Energy is measured, and work also. Work and energy are both measured in joules. So you can get energy from lots of places. We call these energy sources, where we get our energy. I want you to pause this screencast, and on Google Classroom there is a link to this video, and you can see that it's the link that has like teacher's domain, energy source in it, and I want you to watch that. It's about a 6-minute video talking about energy sources, electrical, different things like that. So go ahead and pause the video or pause this screencast to watch the video. Did you enjoy the video? Great. Okay, so now let's talk about that first one on the list of the forms of energy was mechanical energy. Before we get to what mechanical energy is, you have to know that there are two types of mechanical energy. We have our potential energy and kinetic energy. Potential energy is an energy an object has because of its position or shape. We also call it like stored energy. It's energy that has the potential to be used. It's storing it up. It's ready to use it. It's not using it yet, but it's ready to use it. Then we have kinetic energy, which is the energy of motion, meaning that energy is being used right then and there. When it is being used, not just storing, but it's being used, we call that kinetic energy. And I'm going to show you an example of that in just a minute. As you can see, when you take the two of them together, that creates mechanical energy. Mechanical energy is the total energy of motion and position of an object. So it's kind of like you're taking potential energy plus kinetic energy equals mechanical energy. And go ahead and take a minute and write on your notes. Now, on your notes where it says definition, the total energy of, unless you have the new notes that I've created, then there are 3 spots where it's like line, or line. You have one too many lines. It should just say line and line of an object. So go ahead and you can make that note. You don't have to have 3 things. Basically, you're looking at motion or position of an object, or the 2 words that you're writing down. Now, I'm going to take you to another video, or not a video, but I'm going to show you an example of potential and kinetic energy. Now here's a roller coaster, and you can see on the this circle right here, when it's pink, the roller coaster is showing potential energy. When it's blue, it's showing kinetic energy. So first I'm going to play it through just so you can see it. So you can see a lot of stored up potential energy, and now it's using that energy, kinetic, potential, kinetic, a little bit of potential. As it got to the really high hills, it was almost all potential up here. And as it was going down, it was using that energy, so it was kinetic. And as you notice, it got a little bit less when the hills were smaller. So now let's go step by step. So on this very first part, we have tons of potential energy. It has the energy of motion, where it could go. Then, as it's going down, it's all kinetic energy. It's being used at that time. And again, starting to build up some potential energy. Lots of potential energy. Just a little bit of kinetic because it's got that momentum that keeps it going. And as it goes down, it's all kinetic. It's being used. Little bit of potential energy, and then all kinetic energy. So that shows us kind of on a roller coaster how that would work. Keep that in mind, and you'll be able to go back and look at this when we do our marble roller coasters, where your points of potential energy are and where your points of kinetic energy are. Okay, so moving on, I want you to let's see, stop the video. Again, stop this screencast, and I want you to go to the video that says Teacher's Domain. It has this right here, the ZSPL car. You're going to go to an old kids TV show called Zoom, and they're going to show you some potential and kinetic energy actually at work. So stop the screencast to watch the video. Wasn't that cool? You could go and try that at home by creating the little cars that they had. Now let's talk about energy transfers. So when an object does a work on another, when work is happening, energy is transferred from that object to the other object. So energy transformation, basically, when work is done, on your notes, energy is transferred from one object to another. So energy transformation is a change of one form of energy to another, and it can be different types of energy too. For example, when you use a hammer to pound a nail into the board, you're transferring that kinetic energy to the hammer, and the hammer transfers the kinetic energy to the nail. But energy is also produced in the form of sound and heat. Now, looks like there's a video link on there, but I don't think that one's working, so we're going to skip that one. But go ahead and fill out your notes there on energy transfer. Energy, anytime anything happens with work, energy is always transferred from one object to another. Many times, heat is transferred along with that, sound and heat. Like on a hammer, you're going to hear it, and there's also going to be a little bit of heat on there. Okay, so here's an example of different types of energy being transferred. Creating electricity from coal. I want you to, again, pause this video, and I want you to watch the, there is about a 9.5-minute video I want you to watch, so pause the screencast and watch this video from YouTube on the same Google Classroom. So pull that up and watch that, and then you can come back to this. Cool, hopefully you enjoyed that video too. So let's take a look at, here's an example of an energy transfer. So we're going to see if you can guess which one it is. So in the 1800s, trains used coal to power steam engines. Which is the most accurate representation of energy transformation in the train's engines? Is it A, mechanical to chemical to heat, B, chemical to heat to mechanical, C, mechanical to light to electrical, or D, chemical to electrical to mechanical? So let's think about this. It's using coal. Coal, when it's burned, it changes. That's chemical. And the chemical, when it's burned, produces heat, which makes the trains run and puts the train in motion. Remember, kinetic energy has potential where it's stored, and then kinetic, it's actually moving. So the answer would be B, chemical to heat. So the coal changes, creates heat, makes the train run to mechanical. Okay, so then we have this thing. This is one of the laws in physics. It's called the conservation of energy. The law of conservation in energy. It states that energy cannot be created or destroyed. You cannot make new energy. You cannot destroy or get rid of energy. You cannot create it or destroy it. What you can do is change it from one form of energy to another form, like between kinetic and potential. It can be transferred to different forms. It can't be created or destroyed, but it can change forms. So anytime energy is converted, some of the original energy is converted to thermal energy. Remember, thermal is like that heat. So think about when you turn a light bulb on, that electrical energy. If you touch a light bulb that's been on for a while, it's going to be hot. You're probably going to burn yourself because some of that energy is thermal. Microwaves, that radiant light, it turns it to heat. Car engines, if you've ever felt the hood of a car after it's been running, you'll notice it's hot. So even though it's mechanical energy running the car, it still has some heat energy in there. Rail lines, if you, now I don't go do this, but if you were to touch the rail after a train has gone by, you would notice that there is heat on that also. So almost always anytime the energy is converted, there's going to be some thermal or heat energy along with that. So again, you can see here's a light bulb. Like some of the energy is converted to thermal energy. It makes it feel warm. It's converted to light energy, the electrical, but it's warm because of the friction in the wire. All right, so heat versus temperature. Now at this point, you're finished with your notes, so you don't have to worry about the notes any longer. But let's take a look at this, heat and thermal energy. So thermal energy is the total energy of the particles that make up an object. Their matter is made of atoms, and you'll learn that more in 8th grade when you do chemistry. Atoms are in motion, always in motion. And things that are in motion have kinetic energy because that's the energy of motion. The more kinetic energy it has, the more thermal energy it has. Think about these little atoms that are running around, and the more they run around, the more heat they produce. So a hot object has atoms that are moving around rapidly. A cold object has atoms that they're just kind of vibrating. They're in fixed positions. In other words, they stay put. They just might be vibrating a little bit. And so it's colder. So it's kind of like ice versus steam. Which has more thermal energy? If it's cold, there's not as much thermal energy. Steam is going to have more thermal energy. So temperature. Temperature is the measure of the average kinetic energy of particles in an object. Kind of a big word. This is not something we're going to go into a lot, so don't worry too much about it if you don't understand that. Heat, though, is the transfer of energy between the objects that are at different temperatures. So think about this. A drop of boiling water falls under your hand. Or a pot of boiling water falls under your hand. What's the difference? You're probably going to get burned with the pot because there's more thermal energy in it than you are with one little drop. You might be like, ooh, ow, that hurts. Whereas a pot is going to be like, oh my goodness, I have burns all over my hand and that hurts a lot more. So hopefully you enjoyed learning about energy. Make sure you've watched the videos that are connected with this. Feel free to go back. If you missed something in your notes or something that you're not sure of, go back and look at it again. Take the time to fill out your notes. Please keep your notes with you, and we will use those as a resource at another time. Have a great day, guys.